like to welcome everyone for one of our regular monthly events on behalf of BCS Cybercrime Forensics, BCS Hampshire, BCS e-learning, OWASP Cambridge, and the Anglia Ruskin University Cybersecurity Research Group. I'd like to welcome our speaker today, who's Dr. Mohammed Gahan, who's going to be talking about towards efficient automation of digital crime investigation using reinforcement learning. Mohammed is a Assistant Director of the Cybersecurity Research Group at London Metropolitan University. I'd also like to advertise to members with a number of BCS competitions running, particularly BCS Cybercrime Forensics has an event, has a poster competition, both for students and for an open category. We will pass details around in the chat during the session, but the closing date for that is the 31st of March. And there are several other competitions which may or may not be of interest to participants, but please do have a look. Just to also let you know, we will have a series of further events organised. There's another one for the 23rd of March, and we have events now for April, May and June, I believe. So we do have a programme, and there'll be some other extra events being scheduled as well. Without further ado, I would like to pass across to my colleague, Dr. Mohammed Gahan, who will begin his talk. Thank you very much. Thank you.
Thank you, Adam. Hello, everyone. Can you hear me? No. Okay. Hello, everyone. My talk today is about something which I really care about. I started doing this as my PhD and extended to my current research, which is applying machine learning, or especially reinforcement learning, into automating sequential decision making process like digital forensics, especially. So about me, I'm coming from computer science background, but with more digital forensics experience. So I did my BS engineering degree, it's 5 years degree, then MSc, and finally PhD in cybersecurity. I'm a fellow of Higher Education Academy. Currently, as Aden said, I'm Deputy Director of Cybersecurity Center, which I'm trying to mostly applying machine learning and artificial intelligence to accelerate and to enhance the process of digital forensics and offensive cybersecurity. I'm coming as I'm not like I was not all time academic. I worked long years in industry. So of course you should be certified to work in industry that long. So I have CISSP, CEH, certified JAC certified forensic examiner, some FTK, in-case and XRY certifications, and recently CPSCI as well. And recently we implemented the Digital Forensic Laboratory here in London Met, which enabled us to do all this research now. And we can see many results coming out of this. My presentation will be 20% general, because I have to introduce the topic which I'm going to talk about. And then we will go to specific things regarding what we have done and why and how and what we have got so far. So let's start by digital forensics. I think most of you are quite familiar with. It's a scientific process, and it's quite complicated as well, because it includes preservations, collections, validations, a lot of analysis and interpretations, in addition to some, let's say, heavy duty things like documentation, reporting, and so on and so forth. It is done for one reason, which is trying to find out if somebody committed crime or not, or policy violations, and therefore we look here to reconstruct the events before what happened, and help to, and sometimes in incident response, we try to anticipate further damage. There is different branches of digital forensics. People who work in industry will say that it's getting more and more complicated. When I started my career, it was mainly computer forensics. few years after, we had this mobile devices coming, and we started looking more into mobile forensics, and then all this online communication, companies being online, everything being online. So here we had more about network and database, and and we are moving now towards more IoT and mobile devices forensics rather than a normal one. However, the procedure itself will change depending on the environment we are dealing with, and the aim stays the same. I just like this picture because it does shows how difficult is nowadays digital forensics. This is one person belonging, IT equipment belonging. If you are in the IT and you are working, you can see this somebody having all these equipments: laptop, tablet, desktop, maybe mobile devices, plus a couple of IoT devices. This is something we see on a daily basis, and all this does generate loads of data. And this which goes from normal emails to pictures, graphics, financial transactions, spreadsheets, databases, and goes to more and more specialized things like, for example, location, GPS positioning, logs, video and audio, and so on and so forth. So this picture does summarize how digital forensics is today's versatile. And we look into all this data to find the evidence, which is our piece of information that will help us to support the conclusions. It might be something very small. It might be more than one thing. We might end up by investigating a more serious crime, starting from a simple policy violations. So, and the data here is subject to a very strict protocols, and everything is recorded, and we try to prevent as much as we can. It's not always the case. It's not always possible, especially when dealing with mobile devices. But at the end of the day, we try to keep this process as much secure as possible and as much legal sound as possible. This is the normal process, and I believe most of you are quite familiar with. Some people likes to split it into 4 steps, which is collection, examination, analysis, and results, while others prefer the 5th one, which is identification, preservation, analysis, documentation, and presentation. But what's interesting here is how we move from the media device to the evidence throughout this process. So we start from something bigger, we look into the data, we identify information out of this data, and finally try to find evidence out of all these informations we have. And this requires skills, and these skills are becoming more and more problematic. Myself, before joining academia, I used to be a team leader in CROL, cyber forensic team. And one thing I had to see, to be honest, is that there is a big shortage in the skills we have. We used to hire graduates and even people in mid-senior positions and they didn't show that much expertise in doing what we were requested to do. And I remember they were, at least the few years I spent as a team leader, how many questions I had to answer on a daily basis, how many times I had to step up and help, and we cannot help them. The practice itself is getting more and more complicated, and skills required are huge in terms of time you need to get all the skills. So in addition to normal cybersecurity skills, in addition to computer skills, investigative skills, there is other things like understanding and knowledge in things like, for example, cryptography, intrusion detections, and how intruder works, cyber threat intelligence, CTI, and all these things that makes the work of cyber forensic investigator much more harder than others. And just before we finish this first this first phase of general introductions, I would like just to give something about digital evidence, which is the 2 types which we usually deal with in terms of evidence. I know there is more, but for this presentation, I want to focus into this 2 category. The first one, which is the persistent data, which stays of course, after switching off the machine, if we just take it as it is. And secondly, is volatile data. And let's talk about here data like processors, RAM, registry, and all these browsing things that can just vanish after we switch off the machine. All this will take us to something called the challenges we have today in digital forensics. And the first one, everyone will tell you that the explosion and of complexity, as I was explaining earlier, is huge. And the evidence is no longer confined within a single host. If we take example of our phone, if you got an iPhone, for example, you're more likely to be in a situation where you don't know if the evidence is actually into the phone, into the iCloud, or the application server. It's getting more and more harder and split here and there. There is also the development of standards, which are lagging behind nowadays in digital forensics. There's no standard format. There's different formats, different type of files, and you keep seeing new things on daily basis. There is a third big problem, which is the privacy preserving in terms of investigation. If you are doing investigation, someone doing financial crime, are you, as an investigator, should you have a look into the entire content? How can you restrict this? Is everything relevant for investigation? Should we navigate everything, or just this something has to be limited? This is a big topic, but some countries are trying to introduce new legislations. I heard recently that US actually is trying to move towards to enforce limited search warrant, which used to exist, but nowadays they try to enforce it. I think the final, and also there's issues, challenges with the legitimacy, and finally the rise in the use of anti-forensics techniques. If you pick up any one of us, you find yourself at least using one or two anti-forensics techniques without, even sometimes without your knowledge. I was just surprised when I was teaching my students one module called digital investigation, and I had to find an example of how to use anti-forensics. And guess who was the best example for me? She was the ex-candidate for US presidency, Hillary Clinton, using Glitchbit for deleting all this kind of evidence here and there. And if it's happening within politicians who are from like me, from generation when we use technology in a very moderate way, you can imagine how things will come with new generations. And how things actually will be hard in terms of investigations. I personally like to use this graph to show how things are getting harder. The first one, just try to see that the volume of the evidence, the high level of complexity in accessing some of the content, like for example in iOS devices or in some encrypted disks like Dell or something like this, in addition to the uses of anti-forensics, will make the suspected offense hypothesis very hard to be confirmed. And the second thing, which is much more better, it's from a research paper, I put the reference later. It's how the barriers we put as an investigator will prevent us to see the full pictures. Because if you are a police officer and in charge of digital investigations, and they bring your case, it's a homicide, you just have to look into things that are related to homicide, and maybe this will make you ignoring or just walk past something that is much more interesting or much more severe. I don't know what kind of things can be much more important than homicide. I think something with national defense or national security or something like this. But this is something that is happening nowadays because of one thing, which is the cost of investigations and the time restriction we are imposing for this investigation. At the end, all this will bring us to the big four challenges, 4 V's, which are the volume of the data and the variety and different type of files, data within different mediums, and how hard it's getting into this content. The velocity, which is to do with the amount of time needed to process and analyze this data. And finally, the value of the data, which is not actually the resale value, but the value from the actual intelligence collected, and when the data is being processed correctly. I think people in national security, this is their biggest concern when they are dealing, especially with cyber forensics. And this is where all the artificial intelligence idea in digital forensics comes from. We try to address this 4V. We found out that actually AI, it can help us to address some of these things. For example, we can improve things when it comes to chasing the evidence and conduct more in-depth investigations, because an automated system doesn't have a limit into the capability you can give it processing power. So therefore, they can work overnight. There's no problem. We don't have working hours. It's much more faster, and we can talk about this later. And also about helping us to identify critical forensic evidence, which are not usually seen or found, highlighted by human because of the lack of time, because of lack of expertise, and many other reasons. This takes us to the third ground, which is covering more ground. Human is human. Human have a limited capability. If you restrict a human and give him a very small amount of time to complete the tasks, of course, he will just look into a very few things, and therefore the coverage here would be less and less important for him. And finally, there's something which is already done, to be honest, with the current automations. Is quite enough, but it might be improved using artificial intelligence, which is reporting. Sometimes the weakest link here is the reporting from the staff. They can do a very good job, but when it comes to the reporting, it's a little bit hard. And here take us to the use of AI to make sure that this system can complete tasks as normal as a human intelligence. It can make decision and make this works in reality. These graphs here basically give us an idea what we are expecting to consider if we want to make one of digital forensic tasks or activity more efficient, not more automated, because it's already automated. Machine learning is what comes first, and within this machine learning, we have to find out what kind of things we try to do. Of course, before it comes to machine learning, most of us will go through what two very common domain of applications where they helps a lot into improving the efficiency. The first one is the expert system. Even though this is quite old solution, but it's very efficient. I did myself develop it. Now we're trying to get a patent for this. Expert based for penetration testing, which is expert work. Sequential decision making, and it's quite effective. And decision tree, which is actually being used in by human. Why not making this automated and have this as a way to move this practice forward? And all this will take us to why should we go for reinforcement learning here? And the answer is that reinforcement learning is for sequential decision process. Okay, if it's for sequential decision process, what digital forensics is about? Yeah, actually, digital forensics is about making decision from an expert, and this decision will take them to make another decision and look into something else and make a decision open this. So at the end of the day, it's sequential decision making, this digital forensics. So reinforcement learning agent here will be able to mimic the human expert. So and make decision making, sequential decision making. And also, reinforcement learning is very powerful in point that the reinforcement learning agent can just be assigned what to do. You don't give them any information about how to do it, just what to do, and then you can help this agent determine which is ideal or best behavior in terms of making decisions, just by controlling the rewarding system, which we will explain later. And reinforcement learning is very good for repetitive tasks, especially when we do the same thing more than once. In digital forensics, this is common especially, for example, if you are making an investigation on computer and you have more than one session. Let's say, take one of our computers here at university being used by more than one student and staff. You will end up by having to do the same thing for all the sessions, which is actually painful things. Can you imagine a robot who can do this in much more efficient and much more automated way? And the good thing about reinforcement learning compared with other type of artificial intelligence is that the human intervention here is almost zero. The system will learn by rewarding or punishment feedback. It's like the carrot and stick, which make things working much more smoothly. That's what makes us to think that this is something we can have it within our digital forensics system and tools and framework. And also, we have this, what we call action, effect, and rewards. This is what's the basic of reinforcement learning, and which is basically characterizing the digital forensic and incident response practice. And the last point is that reinforcement learning will allow us to perform and reach a result much more faster than other machine learning techniques. And the last one is that which is actually most important from legal point of view, especially when we have to go to the jury and you are expert witness presenting the work, is it does enable us to provide explainability what we are doing, because it's good to have a system, a black box system, but if you cannot explain what are the steps or what are the criteria on how this system came to this conclusion, it's not something we can have in digital forensics, because remember, we have to go to the jury, you have to present your findings, even at corporate level, you have to present this in your boss, and you have to make sure that this is technically sound, and you have to basically defend the case. And also, there is some stuff that will contribute in digital forensics that reinforcement learning might help us to contribute to. For example, as we all know, and we just introduced, that digital forensic practice is rapidly evolving and is getting more complex environment. So looking into this problem as a market decision process, which is the simplest representation of digital of reinforcement learning, it's something very, very actually, it makes sense from a scientific point of view. And that, however, there's some other issues which might be problematic, because this dynamic environment will make complex the process of creating or representing this as the problem as MDP or market decision process. Also, the rewarding function is very tricky. And as we said, relying on human rewarding is not practical, or sometimes unsafe. It's not practical when it comes to having human to weight system finishing and confirming or rejecting, or it's unsafe when this human is actually not really expert, he's not really knowledgeable, and we have seen a lot in industry. It doesn't mean that you are certified or you have years of experience that you know everything. So who is actually this perfect expert that we can rely on in terms of assessing or rewarding system? And there is also great part of uncertainty, especially in incident response, when we have a lot of probabilistic output. And this is something very problematic from scientific point of view, because if we want to consider the partially observed Markov decision process, which is the version of Markov decision process that accounts for probability, this becomes much more problematic in terms of solving the problem. It takes a huge amount of time, and it's technically very hard to implement, if it's not impossible sometimes in large problem. Also, we have to work out how to capture the expertise, which are sometimes relative to the process, how to make this generalized and use it in the future. And finally, as we said, the scaling up. Can we solve all kind of problem? Can reinforcement learning take over human in all kind of problem? Okay, if it's possible for small cases, for small amount of data? Is it possible for larger? And scanning a problem is one of the key issues. But we know from experiencing that reinforcement learning will at least provide 5 big contribution to digital forensic practice. And the first one, as we just explained, is the explainability. We can explain what the decision-making logic is behind the machine picking, and we can understand this. It's also the interpretations and the probability of the data, so we can communicate and explain meaning what as comprehensible way. We can understand our intelligibility, which refer to the model will allow self-explanations. It does allow us a transparency in terms of algorithm transparency. Reinforcement learning is doing much more better than other machine learning techniques. And finally, it's quite comprehensive, so it does give us more options and more includes more models and describe learning process and comprehensible manner. Let's now go to what we have done in this our research, which is still in progress, but we are seeing the first results coming. The first thing we had to do is to study the Markov decision process. And for the people who are not from from artificial intelligence background, which is most of us, Markov decision process is composed from 5 components. We have what we call the state space, which are different states that systems comes in. We have the action state space, or A, which are all the feasible actions. And we have the rewarding functions. We have transition functions. And finally, we have discount factor. And reinforcement learning works in this way. If we have here, for example, this is our environment, different digital evidence, and we have the agent who will basically take an actions, receive a reward, and move from state to another, progress to the states. And of course, we can save this into memory, and he will be looking into learning the best policy into a policy that maximize the rewarding. So in this research, what we had to do, we have to make choices. And one of the choices we start with is, should we work with a model-free reinforcement learning or model-based one? And of course, here it will be case by case. But at the end of the day, after studying 3 or 4 domain of application, we found out that actually it has to be a model-based. We cannot have a model that covers the entire digital forensic practice, because it will be too big and not very practical. So what we did is we create a model for each of the practice. Malware investigation is something, let's say, steganography detection or something like this. They have their own model. Registry forensics, which we will start with, will have its own model. And then later stage, we had to decide what kind of learning we're looking for. Is it we try to maximize the value? No, this is not, of course, what we want. We want to make system to learn how to do things and do things automatically in the future. And therefore, what we decide to do is to opt for a policy search, is learning the best policy. So this will be captured and used next time directly if we see the same context. If we have a state, and in this state, you decide to make an action. Let's say I'm in the state A and S, and I want to make action A, and this will take us to the best possible output. So you get a good rewards. This will be saved later. The system later, if you see the same thing, it will automatically does the same thing automatically, and therefore this will save us time. That's why reinforcement learning is so good. I just put here on the right, for people who are not from digital, from artificial intelligence background, the different modeling of option we had and the different solving options. And of course, here we try to go to the direct policy learning, and we had to establish metrics to see if the system actually is good or not. So we had to do the rules of the game here. And for us, the rule of the games are 2. The first one is the time, because we know it's time constrained activity. So the shorter time it takes the better it is. And time in this case is the cost, because in digital forensics, usually I used to work in hourly rate, for example. It gets up to £150 an hour sometimes. So the more time you cut the cost, the better it is for the cost. The second metrics here is the covered artifacts. I think we talked about this earlier. Is how much we covering in terms of the digital evidence. Are we looking for everything? Are we not just ignoring things? And this will basically works towards the result reliability or effectiveness. Of course, there's other metrics we can have, but like, for example, success rate. But I believe this is something subjective, because it doesn't mean that you don't find. Sometimes you are investigating case and there is nothing that proves that the suspect have actually committed the crime. So this is and there is no success here in finding the artifact, but still it's a good resource for us, because this is the output of digital forensic investigation. So this is something we are just going to ignore. Okay, this is a work we are doing now currently with a PhD student at our university. He's doing a PhD on using reinforcement learning into incident response. And this is just an example of how things works in malware, for example, investigations. In malware infections, we work with live memory. That's what we explained earlier. So we have a live memory dump, and we try to image information. We do what we call image information detection, detect which operating system is this, which version, so we can apply the relevant scripts. And we do what we call system profiling, detecting all this. And then there is a set of activity we can do. But this activity are kind of people who are doing this on daily basis. I think they should know about it. It's sequential. And sometimes you don't have to do all of this. It will depends on the context. Which kind of malware is this? Is it a ransomware? In a ransomware, you can do something. If you have an adware, for example, you can just ignore this. So this setup activity, I don't want to make this this is just an example. I don't want to just go through this in details because it's too technical. For example, PS list detections is something very common from any memory dump detections and PS scan. However, the DLL lists is not done for all cases of malware infections, for simple reason that is not relevant for some of them, like for adware. Hive lists, for example, detections and print key are very optional and depends on which kind of malware we are talking with. All this will take us to think, how can we make this as a Markov decision process, and therefore it will be state, action, and reward. And we actually did this on many scenarios, ending up by having something like this. We start by the memory dump, and we end up by deciding, is there a malware really or no? Is the file malicious or is just being file? It does go to a lot of things here in the meanwhile, and the rewarding things here, we're not saying that it's 100% sure how we are rewarding, but at least this will help our system to move forward. In the future, this basically can be improved more and more. But what I'm doing personally, this is what our latest research and is currently in writing up, is about applying reinforcement learning for registry forensics, which is one of the most common cases that takes long hours from our experts, or from digital forensic experts. So as you know, most of the people know that the registry is a central hierarchical database, which basically store plenty of informations about system configurations and about users, about applications, about hardware. So this is a kind of the big Alibaba tavern where you have to find plenty of things. That's why a lot of people in digital forensics call it the gold mine for digital forensics. And there's plenty of things there, like hives, which are binary database files. We have the keys and subkeys, which are analogs to what we call the folders. And this will include values and types, and interpretation is very, very, very technical. some people are very specialized in Windows registry, while others are very, let's say, they just have a very superficial knowledge. By the way, there is very good resources from the Science Institute on the poster for registry forensic investigation, which we use for academic purposes, but it's also very useful in industry. Some research has been done to create something to define the workflow in registry forensics. Usually, it has 3 or 4 steps. This will depend on which approach we're going to do. It starts by preparing the input, pre-processing the input, looking into the raw results, and trying to normalize and answer the questions. Whose PC is that? Who is the user? When was the last? Plenty of questions that you can answer, like, for example, when was the last logging time? Was it connected to a network at the time? Who is the user who logged? And this software has been used. What are the last typed URL? And so on and so forth. So all these kind of things that will try to answers take us to something like this. I've just took something very simple to explain what we have done. We started from a registry, Windows registry. We imported, which is evidence registry, which you can do with FTK registry viewer, or with like editor, which comes with our Windows. And then how things works, we start by taking a decision. Let's say look into HK local machine, then take us to the SAM. If the SAM, we have look into CID, system identifiers. If it's 500, that's mean that this is actually the root or the admin. If it's something like this, we look into if the SAM network was being enabled, and then we look into the last logging time and date and time, and if this also there was other users. It's basically a repetitive and sequential process, which end up by being represented as a Markov decision process as follow. For example, we have the list of states, different application here. We start by having the host key, classes, the current users, the local machines, and so on and so forth. And then we move to more specified registry, the SAM security system and software, and the NTU.dat. And for this, then we go inside, like for example, for someone, as you know, if you see SID, it's sometimes unknown. This is state when we don't know the state of the SAM. But if it's 500, that means the root. If it's 501, it's the guest. And different users have something from 1000 and above. And also if other information like the last logging time, last logging time, and if it's blank, there is no information. So or there is date and time input. Sometimes it's about a binary input. So is it password protected? Is not, and so on and so forth. Is it network enabled? Is not. This is kind of network. And the action here in our case is something like this. We start by importing the registry, we extract the hearts, we parse the SAM, we examine the seed, the accounts, and so on and so forth. This is something just to explain how things are represented as from the normal registry forensic process to make it as Markov decision process. And this will take us to basically to solve this problem. Once we have the Markov decision process problem, we have to solve it. And we use for this solve POLDP, which is actually extended or out of the box solver. And what we have received is a very, very good results. Not because of the time, of course, but other results. For example, this will give you an idea about the time it takes to solve a 500 state problem. If you go back here, this, for example, this example have 1,034 states. There is other bigger problems that can go to 2,500 states, and the time it takes to solve from with this problems, the smallest one we could get is something around 500, which is from an XP machine, Windows XP. The most complicated one is my machine actually, which is 2,500. It's a Windows 10. So we tried to look into how the system behave in time, and of course the time increases, but not that much. Actually, we see this small increase in terms of is 10 to 6 to the power of 6 seconds here, and this is the number of spaces states we have in our MDP environment. And as you can see here, we try to use different epsilon just to see how this will help the system to converge. And as you can see, something like around 95 is the best things we can, because it lies just in between, and we see a much more clear pattern. Of course, this will include what we call standard deviations, and this is thousands and thousands of results we had to do, and we changing things and do it again, and add one state and do it again to get something like this. So as we can see here, the worst case scenario here is about 3 million seconds, which end up by having a very good amount of time. Like for example, if we go to 3 million seconds, is actually it's 833 hours, which is not something very good initially. But when we do testing, retesting again and again, it will improve, of course, because we have to start from something which is what we call initial beliefs as well. So, but what we can see in terms of resource enhancement is more about how many artifacts we are covering, how many artifacts actually we are looking into. And as you can see here, in 2,500 artifacts, we are reaching something around 450 artifacts. 2,500 state cases, the bigger one, we are investigating for 450 different artifacts. From my own experience, I did this work for a long time, and I can assure you that the best digital forensic investigator wouldn't cover more than 25, 30 in this case, because they just go to things that they want to look into and not everything. In this case, it will extract data about very, very, very detailed things, like not only the crime we're looking into, but something else. For example, if there was unauthorized access, if there's somebody who tried to hack into it, and so on and so forth. Some things that you are not even aware of, if this computer is being used by somebody else, and some other things that we can extract from Registry, plus the applications things, which basically confirm our work that reinforcement learning does contribute a lot to our Registry forensic investigations. It does cost the time, which is a cost as well, and makes the practice, which is much more important, more accessible for non-experts. So nowadays, we have somebody who is new to the practice, you can just ask him to do something, and this will help us. The system can work as a user assist in the worst case scenario. This is basically will enable them to do more highly technical tasks without having this high level of knowledge. It allows something which is very important, is the reuse of the data. When we do an expertise and we decide a policy on acting on this case, this is something we can extract and use it automatically in the future. And the last thing we have seen is that this minimizes the risk and mistakes. And therefore, in a legal system, this will minimize the risk of miscarriage of justice, where human experts just ignore some informations and end up by having an innocent person in jail, or actually criminal walking on the streets. So to conclude our presentations, we can say that reinforcement learning works. I think everyone knows this, but it works very well in digital forensic context. And we tried this at least now for 2 domain of applications. One is on live data, which is the RAM for malware analysis. And the second one is on registry forensics. Of course, the proposed model we have here as MDP is showing that it fits the purpose. Registry forensics is quite easy to start with, and this is why my choice was to go through registry forensics. The enhancement of performance is good, but in bigger problem, I think we will have to move towards hierarchical modeling of MDP. Let's say split this by user or something like this. And also, the last thing we have conclude that any reinforcement learning system, it will definitely exceed human expert in terms of coverage and exploration.